Here we have an example of sets that do not contain numbers. These sets contain, well, individual species. This is a list that talks about the endangered and threatened species of a couple of various groups. So it looks like in this chart we're only talking about endangered and threatened. So you can see there's 101 endangered species, there's 52 threatened, and in total, of these amphibians and reptiles, there's 101, 52. And in total, there's 153 species that are either endangered or threatened. You can see that those two numbers add up to give me this one here. This is not saying that the total number of amphibian and reptile species is 153. There's loads more than that. So let's see. I'm just kind of looking to see what this is. We also have, we have various other groups of species, and we're being asked to describe E intersect B in words. So E, let me just read through here. E is the set of all endangered species on this list. B is the set of all birds. So if we're talking about E intersect B, this is going to be species that are endangered and they're birds. I'm saying and because this is the intersection. We need both of these things to be true. So overall, this would be endangered birds. And if I wanted to say what the size of E intersect B is, this N, remember this means the size of the set. This is not describing the actual elements in the set, it's saying the number of elements in the set. So E intersect B, well, all the endangered species occur in this column, all the birds occur in this row. So it turns out that one, this number right here, is, you can see it's both in this column and in this row, so N of E intersect B is 256. Alright. Let's see what happens when we flip it and talk about a union. E union B. So again, E is all the endangered species, B is all the birds. E union B is all species, well, I'm going to leave all off because I'm going to say species that are endangered or are a bird. I'm going to put in parentheses or both here, because in English, the usage of the word or is perhaps a little bit different than the usage of the word or in math and in logic. In general, if you say, let's say it is raining, and it is Wednesday. So if you were to say it's raining or it's Wednesday, then there's kind of an implication here that it's going to be one or the other when you say this in English. When you say it's raining or it's Wednesday in a math type setting, though, what you're saying is either the first one is true or the second one is true or both of them are true. So, if you kind of think about your truth table, this you could go true, the first one being true, the second one being false. You could go the first one being false, the second one being true. You could go both of them being true. The only one that's excluded here is the case that it not raining and not Wednesday. If both of these things are false, then this compound statement with the or here would not be true. So in any case, I digress. If I want to say N of E union B, the size of that set, well, all the endangered species, let me erase this, all the endangered species are here. And we're already given a total of this column. That's this number down here. So if I was to take and add all these numbers up together, it should give me this 238. Similarly, these numbers right here, these are all my birds. And if I was to add those numbers together, I would get 279. So what happens if I take 279 plus 938? Well, you may notice that something is wrong with that. Because this middle number here, this 256, has been counted in both of those. So what I actually need to do here is I could subtract it back off. This number, or the sum of all these plus the sum of both of those minus the sum of, or minus that. Of course, I could have gotten about this several different ways. I could have added up all of these numbers individually. 101 plus 63 plus 256 and so on. Let me actually pull up my calculator and see what I get here, though. Alright, let's pull it down where I can see it. 938 plus 279 minus 256. This gives me 961. So this sort of a technique where I took the sum of the entire first column, the sum of the entire row, and then subtracted off this number that was double counted, we actually have a special name for this particular property. We call this the union rule. I haven't technically introduced it yet, though. But like I said, you could have gotten this just by adding up all these individually. 101 plus 63 plus 256, 108, 185, 325, and 23. You can see we get the same number if I add all of those up individually, but I'm much more likely to make a mistake if I'm adding up a bunch of individual numbers. Alright, so let's do n of E union B. Oh, I just did that right here. That's 961. How about if we do a more complicated set like this? So first off, I'm seeing that the n this is talking about the size of a set. So I know I'm talking about the number of species. But let's say F union M. Let's first figure out what F union M is. F is the number of fishes. M is the number of mammals. So F union M is going to be, well, the sum total of those two. First off, I'm talking a union, so you know, we saw with unions you could start with the first set and then tack on anything from the second set that wasn't already included. Well, none of the mammals would be included in the fishes set, so I know I'm not double counting anything there. And then I want to intersect that, this is an intersection, with T complement. Well, what is T complement here? T is the threatened species. T complement, well, according to this chart, everything that we're discussing here, it's kind of implied. This chart, this would be n of U, for instance. My universal set would be all the species that are present in this chart. If we were talking about a real-life situation and maybe we were able to know the total number of species, we might make U something else, but given the context of this chart, I would say that our N of U is just the endangered and threatened species. That's even the title of the chart. So that means when I'm talking about T complement, I want every animal that's not in the threatened area. But it just consists of the two different species, so that means T complement is exactly E. So that's T complement. I want the intersection of these two, which means I want just these two sets right here. So 85 and 325. So I'll add those together, giving me 410.